MYP3 Unit 2 Chapter 3 is revising standard form, also known as scientific notation, or if you're interested in the Danish name, you should be Den videnskabelige skrivemåde. I have trouble saying that. It means the scientific method of writing, literally. So it's a way of writing very big or very small numbers without having to write loads of zeros. So scientists deal with very big or small numbers like distances in space or sizes of tiny particles, and those numbers often have loads of zeros in, and you don't want to have to write them with loads of zeros. So they've agreed on a standard convention for writing them, and the convention is to write it as something between 1 and 10 multiplied by 10 to the power of something. So for example, I've got the number 46 million here. Now from 46 million, I think of a number between 1 and 10 that uses the same digits. So that would be 4.6, and I need to multiply 4.6 by 10 million to get 46 million. Now the way I've set this out in columns with the numbers lined up helps you to get the right number of zeros. So 46 million written on the top there, and if I write the 10 million underneath it with all of the numbers nicely lined up underneath, I can see that 10 million multiplied by 4.6 gives me a number that's 40 million and a bit, 46 million, because 10 million has got a 1 there in the first digit, but 46 million has got a 4 there in the first digit. So I can see that it's 4 and a bit times as big. So I can see that it's correct that 46 million is the same as 4.6 times 10 million. And then 4.6 times 10 million is the same as 4.6 times 10 to the power of 7, because 10 million, as we saw in the previous chapter, is 10 to the power of 7 because it's got 7 zeros in it. So the point of that is that 4.6 times 10 to the power of 7 is a much shorter, easier way of writing a very long number, 46 million. So the thing to take from this is the method of setting it out, lining it up so that you can see that the 46 million, for example, is the right number of times bigger than the 10 million. Common mistake is to get the wrong number of zeros, because 46 million only has 6 zeros in it. 10 million has 7 zeros in it, because one of the zeros is being swallowed up by the 6 that's in the 4.6. So setting it out like that with the columns and things lined up helps you to get the right number of zeros. I can't recommend that strongly enough. Example 2 is of a very small number that we're going to try and put into standard form. So 0.0000481. I need to think of a number between 1 and 10 that uses the same digits. So that's 4.81. And 4.81 has got to be multiplied by a number that's lots of zeros with a 1 on the end to give us the original number we started with. So I'm starting to write 0.0000. Then I get this far and I see a 4 above it. So if I put a 1 there, I can see that the number I've just written multiplied by about 4 and a bit, should give me the number above it. So writing things out lined up in columns like that helps you to get the decimal in the right place and the right number of zeros. I can see that 0.00001 times about 4 gives me the number I started with. And of course the common mistake would be to carry on those zeros until the end of the number and write 0.0000000 and then a 1 all the way at the end. But if I had a 1 all the way at the end, under the 1 in 481, then the number above it would be 481 times bigger. But having things in the right column, you can see that the 0.00001 multiplied by about 4 gives you the number above it. So lining things up in columns is very important to get the right number of zeros and the decimal in the right place. And then finally, I want to put that in standard form. So 4.81 times 0.00001 is the same as 4.81 times 10 to the power of minus 5, because 0.00001 is a number with 5 zeros in it, including the one before the decimal point. So that's in standard form now, because it's a number between 1 and 10 multiplied by 10 to the power of something. So here's some questions. Write a very big number in standard form. Write a very small number in standard form. Then here's a very big number in standard form. Write it as an ordinary number. Here's a very small number in standard form. Write it as an ordinary number. And then finally some calculations where you're multiplying and dividing two standard form numbers by each other. So have a go at those and pause the video before you look at the answers. So here are the answers. I hope you paused the video. So starting off with this number here, it was 2,700,000,000, a 2, a 7 and loads of zeros. So from that I got a number between 1 and 10 using the same digits, which was 2.7. Underneath it I wrote a number that was a 1 with loads of zeros, and I lined it up column by column by column, so it lined up with the number I started with. And then I can see that the number I just wrote multiplied by about 2 gives me the number above it. So I can see a 1 in the first place, and then above it there's a 2 in the first place, so I can see it's about 2 and a bit times as big. So that's important for getting the right number of zeros, and so that you don't get a number that's like 27 times as big or 270 times as big. You get the right number of zeros. So that's 2.7 times a 1 with 9 zeros, which is the same as 2.7 times 10 to the power of 9. And that's in standard form because it's a number between 1 and 10 multiplied by 10 to the power of something. And of course the original number only had 8 zeros in it, so a classic mistake would be to get the wrong number of zeros there. Number 2, 0.000027. So my number between 1 and 10 is 2.7, and so that's the same as 2.7 times 0.000001. And I can tell that the number I just said is the correct number for this because it's got a 1 in this place, where above it there's a 2. So I can see it's 2 and a bit multiplied by 2 and a bit gives you the number above it. And that's the same as 2.7 times 10 to the power of minus 6, because 0.000001 has 6 zeros in it, including the one before the decimal point. Questions 3 and 4 are working the other way. So we're taking a standard form number and we're writing it in normal form. So 6.3 times 10 to the power of 4, I've written as 6.3 times 10,000, a 1 with 4 zeros. And then I've tried to write the final answer directly underneath with the columns lining up. And that's so that when I write it, I can see that my final answer, 63,000, is 6 and a bit times bigger than the number above it. So 10,000 has got a 1 in the first place, 63,000 has got a 6 in the first place. So I can see that 10,000 times about 6 gives me that number there. I can see it's 6 and a bit times as big. So final answer 63,000. And of course, if you hadn't lined it up like that, you might have got the wrong number of zeros. 63,000 only has 3 zeros in it, but we had 10 to the power of 4, so you might have thought 4 zeros. But of course one of those zeros is getting swallowed up when you multiply it by the 0.3 in 6.3. Number 4, 6.3 times 10 to the power of minus 8. So that's the same as 6.3 times 0.00000001. That's a number that's got 8 zeros in it, including the one before the decimal point. And that's the same when you multiply it out as 0.00000063. So again, important to get things lined up like that to get the right number of zeros. I can see that the number I just wrote has a 6 in this column where there was a 1 above it. So I can see that it's about 6 and a bit times as big as the number above it. So that helps me to get the right number of zeros and the decimal in the right place. Now question 5 was multiplying two standard form numbers together. 6.4 times 10 to the power of 8 was one of them. 3.2 times 10 to the power of 3 was the other one. Now when you multiply numbers together, the order doesn't really matter. So what I've done is change the order of that and put the regular numbers first. So 6.4 times 3.2. And then I've put the power numbers last. And then what I'm going to do is multiply the regular numbers first. So 6.4 times 3.2 gives me 20.48. And then the power numbers after that. 10 to the power of 8 times 10 to the power of 3 is 10 to the power of 11. Remember the rule about adding powers. So that's 20.48 times 10 to the power of 11, but the problem with that is that it's not in standard form, because 20.48 isn't a number between 1 and 10. So what I've done is make that 10 times smaller to get 2.048. Then I've made the other bit of the number 10 times bigger, so instead of 10 to the power of 11, it's 10 to the power of 12. And now that I've done that, the answer I've got is in standard form because it's 2.048, a number between 1 and 10, multiplied by 10 to the power of something. And then question 6, 6.4 times 10 to the power of 8 divided by 3.2 times 10 to the power of 3. Now I've written that as a fraction because a fraction means dividing. 6.4 times 10 to the power of 8 on the top, 3.2 times 10 to the power of 3 on the bottom. Now the trick to this is that you can separately do the division for the regular numbers and for the powers. So 6.4 divided by 3.2 gives you 2, and 10 to the power of 8 divided by 10 to the power of 3 gives you 10 to the power of 5. Remember the rule about subtracting powers when you're dividing powers of the same number. So that leaves us with 2 times 10 to the power of 5 as our final answer, and that is in standard form because it's something between 1 and 10 multiplied by 10 to the power of something.